So last time we taught the computer a skill, a reusable recipe using a function. We built a little program that made tea. It boiled the water, added the tea bag, and waited. But if you think about it, every time we ran the function, the computer made the same tea. It didn't remember what kind of tea you liked or how many cups you wanted. And that's where today's lesson begins. Because if functions are the computer's skills, then variables are its memory. They're how it remembers details like your favorite tea. And that's going to be today's video. We'll be talking about variables. Now, what are variables? Variable is like a tiny labeled box in the computer's memory. You put a piece of information inside, maybe a name, a number, or true false value, and later you can open that box again and use what's inside. Every program you will ever write, from calculators to AI to machines, depends on variables. They are the way computers remember. And in the next few minutes, we will learn how to create them, change them, and understand the different types of data that they can hold. So let's open our Visual Studio and watch this in action, and I will go through step by step. Okay, so let's start simple. So we created the file called variables, and we're going to start by writing our first box, and we're going to assign a label to it. So we're going to call that box name, and we're going to assign Sarah. So what do we have here? We created a box labeled name and put the text Sarah inside it. Remember this, the equal sign here, it does not mean math, where like we're adding numbers 1 plus 1. It means assignment. We are assigning the value Sarah to the label name. Now let's see what's inside that box by printing it. So we're going to say print name, okay? And let's just save this, run it. All right, here we go. So the expected outcomes are Python looks at the label name, finds what's stored inside, and shows Sarah. Think of it like writing someone's name on a sticky note and attaching it to a box. Whenever you ask for that box, you will get the contents inside it. Every time you run code like this, you are teaching the computer to remember something. And this simple idea, storing and recalling values, is what makes logic, games, and even AI possible. But memory isn't useful if we can't change it. So what would happen when we replace what's inside that box? Right now, our variable name stores Sarah. But memory in programming isn't permanent. We can change what's inside that box at any time. So let's see if we can do that. So we can change this to name, or we'll go here to, let's say, Ronnie. Okay. And let's save that. And let's just run it. Okay. So the variable name didn't disappear. We just told Python to replace what's inside the box. So imagine this. The label name is still on the same box. But now, instead of a paper that says Sarah, you slipped in a new one that says Ronnie. You didn't build a new box. You just updated what's inside that box. Behind the scenes, Python just points the label name to a new value in memory. It's like redirecting a tag to a different item, a clean, safe way to update information. And this is very powerful. Once you understand that variables can change, you realize every program, any kind of program, whether a calculator to even goes to AI and neural networks, is just a collection of changing values over time. So let's expand our idea. Not everything we store in that box is text. Some boxes hold numbers, others hold logic. So let's explore the main types of data that Python can remember. So far, our variable held a name, and that name is Ronnie, which is a text. But computers don't just remember words. They remember numbers, facts, and even truth values. So let's look at 3 most common data types in Python. Okay, we're going to write it down here. I might delete this and I'll start with number one is the string, okay, which is text, which we already did that. But let's say drink called, we create a box and we assign the label drink, and then we assign T to it. Then we have integer, which is, it can hold a number. So cups equal 2, a whole number. And then we also have something called boolean, okay, which let's say is hot, and then we give it true, okay, or we give it false. So I'll just put it like this, or false. So we have drink equals T, that's a text or what's called a string. You have cups, which is equal to 2, and that's an integer, a whole number. And is hot equals true, and that's a boolean, meaning it can only be true or false, okay? So let's print it out and see what we get. Print, let's print drink, and then let's print cups, and then let's print is hot. Okay. All right. Let's see the outcomes. Here we go. T, 2, and true. So same idea, different contents. Each of these variables is a little box in memory, but what's inside is stored in a different form. Text in quotes, numbers are without quotes, and logic values capitalized as true or false. And one cool thing, Python figures out the type automatically. You don't have to tell it. This flexibility is part of why Python is such a beginner-friendly and also powerful language. So now you know variables can hold words, numbers, and logical truth. But here's the key. Python treats them differently. Let's see exactly what happens when we mix them. Now that we've seen our 3 basic data types, text, numbers, and logic, let's see why it matters. So here I'm gonna add 2 numbers. Let's say 2 plus 3. Okay, very simple one. 2 plus 3 is equal to 5. So let's print it and see the outcomes. Okay, 2 plus 3 is 5. So Python perform real addition. 2 plus 3 is equal to 5. So now we're gonna make some changes. We're gonna say print 2, okay, plus 3. Imagine, look at this. We're treating the 2 and 3 as strings, and let's save that and see the outcomes. Here we go. So now we have 5, and then the second one is giving us 23. See the difference? So the first one adds 2 numbers. 2 plus 3 is equal to 5. The second one glues text together. 2 and 3, you glue them together, it becomes 23. Same operator, 2 behaviors, because the data types are different. It's like having 2 kinds of boxes. One holds numbers, so the plus sign adds, and the other one holds text, so the plus sign merge them together. And that's the beauty of Python. The same symbol can adapt based on what it's working with. We call that operator overloading. But all you need to remember for now is types change behavior. Okay, just remember that. So every time you write code, it's not just what you do, but what type of data you are doing it with. I'm going to say that again. Every time you write code, it's not just what you do, but what types or what type of data you're doing it with. And that's how Python knows when to calculate and when to communicate. So now let's connect this back to our T example that we did in the past video and see how variables and functions work together to make code flexible and smart. Now let's bring it all together. You remember our function from last time that made T? we can use a variable to decide what kind of tea to make instead of hard coding it. So let's just pull the function that we made last time, which is, I encourage you to watch that in the last video. And then we're going to just make some tweaks to it. So here I need to print the last step, which is the result. And then also let's just remove this. Let's create a new box. We're going to call it my drink. And then we're going to pass, we're going to assign basically a green, let's say. The type of green, the type of tea is going to be green. And then we're going to call the function make tea. And then we'll give the parameter my drink. All right, let's save that. So before we run this, what do we have? We have a function that takes one input called type of tea. Inside the function, Python uses that value in every line, boiling, adding, waiting until the tea is ready. Okay, so if we run this, look at that. Boiling water, adding green tea, waiting, green tea is ready. Okay, the variable my drink stores the word green. When I pass it into make tea, the function uses whatever is inside that box. Okay, what happens if I change the variable? The result will change automatically. So we can just change this to mint. And then we save that. And then we run it. Okay, so result changed, right? Same function, no rewrites, no rewrites. Just a new value in our variable. Functions are the skills, variables are the memory that guides them. Also, inside the function type of tea, right here, is actually another label pointing to the same value as my drink, okay? That's how Python passes information. It gives the function access to what's inside the box. Now that we've connected functions and variables, let's pause and zoom out, okay? Let's summarize everything, the core ideas, the metaphors, and what really makes this powerful when building larger systems. All right, let's just zoom out a little bit. In the last few minutes, we built something that looks simple, but it's the foundation of everything you will learn or you will ever code. A variable is a labeled box in memory. Inside that box, you can store anything. Text, that's a string. Or you can store numbers, and that would be, let's say, for example, integer. Logic, and that's boolean. We saw that data, and by the way, you can do float, for example, which is numbers with decimal. We saw that data types matter. Python doesn't just see numbers and words as the same thing. The same symbol, like let's say the plus, we saw that 2 plus 3 gave us 5 and 23. So the symbol like plus can add numbers or glue text together depending on what's inside that box, okay? Or what's inside the box. Then we combine it all with functions. Functions are like skills, reusable actions, while variables are the memory those skills depend on. Together, they let us build programs that adapt. When we wrote our tea making function, this function right here, we passed in a variable like my drink equal green, okay, or mint. And instantly the code responded just by changing the memory, not the logic. And that's the power of variables. Every smart system, from a calculator, from any type of complex system or simple system, is just variables changing over time. They remember, update, and interact. And that's how computers think. So next, we will go a bit deeper. We will learn how to inspect what kind of data a variable holds and how to take input from a user so your program can remember their choices too. Now that we know variables can hold different types of information, how can we check what kind of data is inside each one? Let's take an example. So we can just either comment this or just remove it. Let's take an example. Drink equal T, which is the same examples that we used, and then cups equal to an integer, and then another boolean, which is hot, equal to true. Okay, and then we'll save that. So we have three variables, again, text, number, and logic. Python actually let us look inside the box using a built-in function called type. Okay, so let's try it out. We'll print type, and then we'll add drink into it. Let's save that, and let's see the outcomes. Here you go. So what do we have here? This tells us class str. So this tells us that drink is a string. Notice the word str. That's Python's short name for text. Okay, let's try that for cups. So we have print, type, and cups. Okay, let's save that, and here we go. Check this out. So this is for the drink, and this is for the cups. So what does that mean? int, integer. So it says basically integer, which means a whole number basically. And then we can do the same thing for print type is hot. It's hot. Okay. Let's save that. Add another bracket. Save that. And let's just run it. All right. So BOOL, which stands for Boolean. True or false. Basically, it's a logic. So type is like a label inspector. It's how you ask Python, hey, what kind of a thing is inside this box? This becomes really useful when you are debugging or mixing different types of or different kinds of data. So let's do a little bit of experiment. So I'm just going to remove this. Let's do this. If x is equal to 5, okay, and then another x, or sorry, y would equal to 5. Sorry, another 5 basically. All right, let's just see what do we get when we print those. Okay, so I'm just going to print type, and then x, and then next to it type of y. Okay, so basically this will give us the result, the type of x and the type of y next to each other. All right, let's save that and print it and see what do we have. Check this out. One is string, one is integer. So both look like 5, but one is a text and one is a number. So even though they look like the same, but they behave totally different from each other. And that's why checking types very much important before you combine or calculate. So now let's make our code a little bit more interactive. Instead of assigning a value ourselves, we will ask the user to tell us what to store inside a variable. And what we're going to use is something called input. So far, we've been the ones putting data into variables. But real programs don't just follow instructions, they listen. So let's make Python listen to us. So we're going to use input. Let's actually write it. So we'll create a box, and we're going to call input like this. And inside, we're just going to ask, what is your name? Question mark, like this. And then we're going to print hello, and name. So what do we have here? Let's see. So here, input is going to show a message on the screen that says, what is your name? So whatever the user types after that is going to be captured and stored in the variable name. So let's try it out. We're going to print that, and check this out. We have what is your name. So we can write anything. Let's say we're going to write Sarah. Hello, Sarah. So what happened is the program remembers what you said. We didn't hard code Sarah. Python took the answer and stored it inside the box name. okay? Let's check the type of this input. So we'll print type name. Okay, so we just want to see what kind of, is it like a string? Is it boolean? Is it a float? Here we go. So we're going to write Sarah again, and it shows as a string. By the way, it's always is going to show as a string, even if you type a number. And I can try that for you. So I'll just run this again, and I'll write 2 here, 2, and it's still showing string. So if you want to use a number, it's going to have the same result. You will, if you need that to show as an integer, you will need to convert it with integer or float. So we can do that right now. We can just write, for example, let's try another example, age, okay? And then we just put input, okay? And then here we'll say enter your age, just like that, all right? And then first I'm gonna print type age, okay? Type age. Okay. One thing I can do, I can just print this right now, and I will show you which expected outcomes is going to be like 4. Here we go. So string. Okay. Now I'm going to do the same thing where I'm going to say age is equal integer of age, right? And then I want you to print age again. But instead, I just need to type, so type of age, okay? So change age into an integer and print the type of age. So now we're going to have 2 different results. Let's see it. Enter age, let's say 23. Here we go. The first one showed as string. The second one, because we changed it, showed as an integer. So now you can store our own data, okay? We can change it and even collect it from the user. So input gives us strings by default, but we can transform them into other types depending on what we need. Now that we can store our data, change it, and even collect it from the user, let's wrap up by connecting all these ideas, variables, data types, and input into one clear mental model. So let's step back and look at what we just built together. A variable is the simplest idea in programming, but it's also the foundation of everything that follows. It's how a computer remembers. We learned this. You create a variable with equal, a label pointing to a value. You can change what's inside that box anytime. Also, variables hold different data types: strings, integers, booleans, floats. Also, data types matter because Python treats each one differently. You can inspect them with type, for example, and you can even let the user fill those boxes using input. Every system, from a chat app to self-driving cars, is built on this same principle: memory that changes over time. The computer stores information, reacts to it, and updates it exactly the same way we do when we think. Variables are how a program remembers the past so it can decide what to do next. Functions are how it acts. Combine those 2 ideas and you've already started building intelligence. In the next episode, we will take this even further. We're going to learn how to make Python decide what to do using if statements and conditions. That's where your code starts thinking logically. Until then, keep practicing, create your own variables, experiment with data types, and make Python remember you. If you enjoyed this video, give it a thumbs up, subscribe to the channel, and click that notification button. Thank you for watching. Take care, everybody. Bye-bye.